I doubt it. But you should always wear long pants in the field and closed-toed shoes, so you just are away from anything that could possibly be poisonous, like poison oak, poison ivy, poison sumac, fungi. You should wash your hands after touching any animals or plants. That's pretty straightforward. End of lab procedures. Always clean up your workspace at the end of the lab period. Unplug all electrical equipment. Ask your teacher how to dispose of all waste materials. Wash your hands. So basically, all you gotta remember: clean up, unplug, dispose, wash your hands. Clean up, unplug, dispose, wash. That's just very straightforward. Now, we're out of the, I should have put like a note that we're out of the laboratory safety year. This is completely different. These are, kind of the rest of this, slideshow, which is a long one, will be, about, worksheets or, things we did in class. So, the running shoes experiment we did in class, Carla is at the mall and she walks past the Foot Locker. She sees that there are 50 different types of running shoes, and she's a fanatic runner. She wonders if different brands of running shoes really help you run faster. Carla's question is, will I run faster in my Adidas running shoes or my Nike running shoes? What do you think? So, the running shoes experiment. What manipulated variable was changed in this experiment? So, I'll give you a while to think up that. What manipulated variable was changed in this experiment? And you've already learned about manipulated variables, so I'm not going to give you any hints. Number 2. What was the responding variable in this experiment? What was the responding variable in this experiment? Number 3, what were some of the controlled variables that should have stayed the same? Just think them all up. More than one, obviously. Did all of the controlled experiments actually stay the same? If not, how could they affect the experiment? Did they actually stay the same? Number 5, in a successful experiment, the responding variable must change based solely, I just thought that was funny, or punny, on changes in the manipulated variable. Is this the case with the runner's experiment? Based on what you know, what was the runner's experiment? Was the runner's experiment successful? Do you think she made a fair decision about what shoes to keep? Why or why not? So remember your answers. Here are the answers. Answer number 1, the manipulated variable that was changed in this experiment was, drumroll please, the shoes you wear. The responding variable in this experiment was the timed record in the run. Some of the control variables that should have stayed the same would be food, distance, where she ran, sleep time, energy level. Those are just all those things. The controlled variables stayed the same. Answer number 5 is no, because every one of the variables in number 3 cannot be monitored. And that basically means that you can't exactly get the exact same amount of sleep, or have the exact same energy level, or have the exact same food. I mean, you could have just one like milliliter more of orange juice, and it could sway your experiment. So no, the experiment, those cannot be monitored. The running shoes experiment was unsuccessful because Carla might have been a little slower on one day or something on the day of the test for a certain shoe. Not everything in number 3 can be tuned to that minuscule degree, like I said. So it was not a successful experiment. We didn't actually have this experiment in class, but this was basically just a little bit of a brain game of could this experiment be a reasonable experiment to do? And this is a commercial that I put it on a TV screen. I know it's kind of corny, but they said this would be a good thing to play because This involves, one, basketball, which a lot of boys are into, and it also involves a manipulated variable of Gatorade Prime, which is what this basketball player, Kevin Durant, of the Oklahoma City Thunder, drinks. So, the Gatorade Prime would be the manipulated variable. The responding variable, what do you think? Is how well he performs in relation to just water. So, let's roll the tape. So there you go. Commercial that was on Edmodo. You can look at it again if you want on Edmodo. Now, for creating data tables, what exactly is a data table? Well, a data table is an organized arrangement of information in labeled rows and columns. The motocross results by state object that we saw was indeed a data table. When you create a data table, start by identifying the manipulated and responding variable. Here's some tricks of the trade. Consider the manipulated and responding variables to determine what observations you will be making. If you plan to make observations to a regular pattern, such as once a day, once an hour, or once every 5 minutes, or once every minute, once every millisecond, if you really want to get down to that, plan to show those times in the data tables. Make a draft of your table. And that's basically just on a sheet of paper. Show all the columns and rows you'll need and what labels they will have. Be sure to write a title for your table. And my data table that I had was motocross results by state. It has to it can't just be motocross or motocross. It can't just be motocross results. It has to be by state. It has to explain some things. Insert units into the column levels where they're needed. Compare the draft of the data table to and by the way, the units would be like milliliters, lowercase m, capital L, or kilograms, kg, stuff like that, pounds. Compare the draft of the data table to the plan for your experiment to be sure you have a place to record all observations you expect to make. And you got to revise the draft of your data table and draw the final table in your notebook. And not on Microsoft Word or Microsoft PowerPoint, obviously, because we won't have the laptop on hand as far as I know. So, this is the motocross results by state data table. Not exactly like what we'll be doing here, but it's similar. So we've got the results, the state, and this is just random states. Of course, I made it up. And let's just say they had a motocross tournament of all 50 states. So here you go. This is what one would look like, and you see a motocross motorcycle there. That's what it should look like. Obviously, without the picture, but it should be similar to that. What you're seeing with the motocross results by state data table there. So now you want to create a bar graph. This will also be gold when it comes down to test day. You will need to know this. The type of graph you should make depends on your data. Here, the diet food effects on dogs are distinct or separate categories. So remember the diet food effects on dogs, the bar graph I did, and I pointed out some fatal errors there. And you remember I didn't have like on the y-axis the weight of the dogs, and then on the x-axis or